This is the Amp Hour Podcast, recorded March 3rd, 2014. Episode 187, with guest Alicia White, Wirewove, worshipping Wookieist.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Alicia White, Logical Elegance.
Hey, Alicia.
Welcome.
Hi, thank you for having me.
Or shall we call you L?
Yes, please, call me L.
L. Excellent. Okay. Because it's Alicia with an E.
Yes, Alicia, E-L-E-C-I-A.
There you go.
Or Echo Lima, Echo Charlie, India Alpha.
There we go.
Oh. How you fly.
And also we should mention, not just of Logical Elegance, but also of our favorite podcast, outside of our own, of course, because we're, ecocentric, but embedded.fm.
Yes, Making Embedded Systems, which is embedded.fm. Podcast is Making Embedded Systems on iTunes and Stitcher and all of the feeds. And it's titled that because that's also the title of my O'Reilly book.
That's right. And
which
we'll
get
talk
into,
all about that.
No doubt. Yeah. Why have we got the competition on, Chris?
Okay, so I was so excited. I don't think you realize. I was so excited when I found Alicia's podcast, which was when you had Jerry on, right? I mean, that was, I think, when I heard about it, and then I talked about it on here.
Yeah.
I was so damn... And this just goes out to everyone else out there. I would love to see more podcasts. I mean, I don't think there's any competition out there because, I mean, first off, It's embedded, and I have no idea what embedded is. And second off...
you analog pussy.
Yeah, exactly. I have no idea what I'm doing there. And then, it's just such a big field. So, thank you. Thanks for doing it.
I didn't know about the Amp Hour before you heard of me with Jerry's show, and... I was so impressed because, finally I get to know what electrical engineers actually do. And I am glad I didn't know about it ahead of time.
Yeah, we talk out our ass. Yeah.
I don't know what I would have done my show if I'm like, well, I could just listen to Chris and Dave and they'll tell me what I need to know. But yeah, it's been really fun. And Jerry's show was probably the biggest one, although Lenore from Evil Mad Scientist, people seem to be pretty into that one, too.
I was listening to that on the way home the other day, and I really, really enjoyed it. I mean, I love hanging out with Lenore as well, and, you've had lots of great guests on there. I mean, James from, Test-Driven Development stuff. I mean, there's been tons of good ones. And you and Christopher, your husband/producer, also come up with great... They're not quite alliterative enough for my taste, but you do come up with great titles.
The titles are supposed to be taken from something embarrassing I say during the show. So it does allow us to really highlight those things I wish would go away.
That's good. Yeah. Like the last one was the Bwahaha lessons or something like that? Or the...
Bwahaha sessions. And the next one's going to be Pink Universes Die Really Quickly. Because
awesome.
That can't be taken out of context.
Right, of course, yeah. Oh, that's great.
Now, even though you do an embedded podcast and you're an embedded software engineer, and worked on all sorts of cool projects, as we'll no doubt get into, you're actually a scientist, not an engineer. Is that right?
Oh, not really. My degree is half engineering and half CS.
Okay.
So
right. Got it.
So I'm in the right spot. But I did go to a school where science was like really, I mean, even more than usual in the engineering curriculum, science was really a big deal. So
right. Okay.
I tend to think myself as a scientist as much as an engineer.
Well, that's good.
Excellent.
I think I personally falter without, I'm kind of a little too hands-on, not enough theoretical sometimes. And I think you and I have talked about the paper side of things. Like how you are really into keeping notebooks and drawing everything out in paper, and I was impressed with that, and also I have no idea how you can do it, especially as an embedded person. I would figure everything would be code.
Oh no, I mean, like today, my mechanical engineer wants me to change how I'm doing some motor control stuff, and I think he's completely out of his mind. It's never going to work that way. And so I ran, I ran all of the pre-tests for how it works now, and I made some code changes, and then I ran the post-tests, and I showed it to him, and I said, tell me how this is ever going to work. And he looked at it and he said, oh, I got those 2 lines crossed. Yeah, I told you.
It's right there.
But it's like proving stuff. I like proving stuff.
You like telling people when they're wrong and proving stuff. Okay, I thought it was more.
I don't like people when they're wrong.
No, really?
I guess,
we love that around here.
So. No, sometimes.
It's like all Dave does.
Yeah, I know, because you're always wrong, Chris. I mean,
Thank you, David.
Just the way it is.
Yeah, thank you. Yeah.
It's not that you're wrong. It's just that I'm right.
Yeah, exactly. Oh boy, I don't have the discipline to keep documentation. I just go, oh no, look, it's so simple, I won't bother, and then it comes back to bite you every time.
Yeah, and if you keep doing it, isn't there like a definition of insanity in there somewhere?
Right. Yeah, yes, there is.
Right, and I think that's how you and I got talking about it, because you were and you've talked about that on your show, and you've talked about that in your book and stuff. But keeping track of tests and stuff like that, and me too. I'm terrible with this kind of stuff. You'd think eventually we'd learn, but no, I think we're just insane.
No. Yep.
Just insane.
No, we're just lazy. I think engineers are inherently lazy.
Yeah.
Yeah. And I don't know if you saw, but I posted where I get my notebooks from. And my notebooks cost a stupid amount of money, but I love them because they lie flat. They have the grids I like. They're numbered. And would I do this if I was using a crap spiral bound notebook? No, I would give up on that pretty quickly.
Yep.
But this makes me feel all comfortable, like I'm making progress, even if I'm just writing things down. And so it's not just writing things down because I'm kind of organized and kind of a nerd about that sort of thing. It's also getting to use the pretty paper. I bribe myself.
So you're an artisan, is that what I'm hearing? You're
Well,
are you a paper hipster?
Yes, kind of.
How is your penmanship?
Don't even get me.
Beautiful.
Oh, my penmanship is awful. No.
All right, checks out then.
Typical engineer.
Yeah.
And
I
you
have
can't
engineer
spell
handwriting.
either, right?
No.
Well,
I can't spell.
Well, the reason I bring this up though is because you have a really good. So I was digging into your book today. A little bit later than I probably should have been, but I was digging into the book, and I really actually like. At first, I was like, "Well, why the hell is she writing about this stuff in I think it's chapter 2, where you're writing about just like drawing out all these different elements and building up systems and stuff." And then I was thinking, I'm like, "Well, where else do you learn that stuff? I mean, is that what made you put it in there in the first place?"
Yes, there's that chapter, and then I think the next one is basically how to read a data sheet, which is like, it's so
really?
obvious. You read a data sheet.
Yeah.
But there are some skills involved with organizing your thoughts and organizing a system so that you can explain it to someone else. And if you can explain it to someone else, then you can explain it to yourself, which I spend a lot of time talking to myself, I guess, but explaining how I think it should work to myself even, and then that helps me. And so the book does spend a while on different ways to draw things because there are different ways to think about things.
This sounds like the confessions of a longtime consultant who's run headlong into this problem over and over and over again. Is that where a lot of this comes from?
Not really. I guess I had been a consultant before I wrote the book, but I had mostly been full time. And now, for the last few years, I've been entirely a consultant. It's more having been a manager, actually. Having hired new college grads and trying to teach them. And even people who are 4 or 5 years out of school, when you're in college, you either get an electrical degree or you get a CS degree.
Right.
And whichever way you come, it's horrible. I mean, you have half your job you don't really know how to do.
Yeah, I'd put it more than half, but okay.
Yeah, exactly.
Well,
Most of it.
probably.
Because there's the business stuff and the mechanical stuff and everything else, but yeah.
But even the junior and junior mid-level engineers, how do they learn the other half? How do they learn whatever they didn't learn in school, and in a way that makes them confident?
That's the tough part. Yeah. So
the book, I mean, there's the chapter about system architecture, which a lot of the software people are going to be like, oh yeah, I kind of remember doing that in school, and oh, this is a good way to look at it. And then the next chapter about how to read data sheets and how to work with a hardware engineer, all the hardware engineers are going to be like, oh yeah, I totally can do that.
Yeah.
But the two chapters together get you an embedded engineer, which is what I want. I want this book to be used by people who are going to work for me, because I'm sick of explaining this stuff.
Yep, that's good. Born out of frustration.
Yeah, read my damn book. Come back on Monday.
What is the hard part about being a consultant is one of my clients asked about how to do IQ math with getting rid of floating point, going to fixed point. And I said, well, I can give you an hour lecture, or you could just read the chapter in my book and leave me alone.
So how did that go over? And then they paid me double.
No, he did opt to read the book and then ask me questions, which is, I feel, is a far better use of both his time and mine.
Yeah, I agree with that too. That's nice. That's really nice. And the other thing I like, I mean, you mentioned, hiring engineers, and I'd like to get into the management side of things, but I really dig that you put in a lot of the questions at the end of the chapter too. I really like that about
the interview questions.
Yeah, I don't know. I just think that it's good stuff. It's like an odd way to sum up, not an odd way, but it's a non-standard way to sum up the chapter, though, right? Like why the hell does this actually matter?
Well, and it's for, if you think about the people who the first 5-10 years of getting out of school, interviewing is an area that you just don't learn. And did you notice the questions are all from the interviewer's perspective?
Yeah.
It's not how do you answer this? It's how do you ask this? Because nobody ever taught me to interview, and it was really hard.
Oh, yeah.
And once you've made somebody cry in an interview, you're like, I suck at this.
No, that means you're winning. You ever made someone cry from a voltage divider?
You've weeded them out, yeah.
It's fun.
But I've seen a lot of people, when I was a manager and people, when we were hiring, and I would get these notes about how different people weren't adequate for the job. And what questions you ask? And people would answer weird things. And I kind of wanted to know, why do you ask this question? What do you expect from it? What do you look for? Is this just a way to weed out people who aren't like you? I want.
Oh, you mean like the desert island question, like that stupid one?
Oh, yes.
Yeah.
Well, in the goat and the cabbage, and you and a boat
and the wolf
have to go across. Yeah. That's actually in the book, and then I make fun of it because it's a question that you have to know the twist, and if you don't, it's a dumb question for finding out if this person can program or if this person understands dealing with resource constrained systems. It's a dumb question. I hate that question.
Sometimes the correct answer can be, that's a dumb question. I
like that.
Yes. I've said that in an interview. People have asked me a question. I go, that's a dumb question. And
have you ever thought about hitting yourself, Mr. Interviewer?
I had a guy who would interview my people, who would ask them, who would interview new candidates. I would ask them, what does this evaluate to? And it would be I equal 5, and then I plus 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 plus. And he would want to know what does that evaluate to? And my response to that is, that evaluates to me firing you for your crappy ass code.
Exactly. That is the right answer. Yeah.
I don't care what it evaluates to.
The practical side. So, okay, so obviously you have a good deal of experience in firing people. Why did you make the jump back? What made you come back to
hiring them?
Yeah. What made the jump back to engineering versus management?
Engineering's more fun.
Well, duh.
I mean, I like getting my hands dirty.
Yeah.
I So every job I've had, they've tried to make me manager. And then finally...
She writes stuff down. Quick. Give her people to talk to.
This isn't a sexist thing, is it?
No, I don't think so. I am
hope
very
it's not.
naturally organized, and I...
Oh, right, yep, and that gravitates you towards, yep.
And
Well,
program
and it
management.
makes the appearance you should go towards that.
Yeah. And I mean, schedules, people look at schedules and are like mystified. And I'm like, oh no, you just do this and this and this. And if you make this bottle point go here, then all work out fine. Nobody will feel too pressured. And once I do that, people are like, oh, well, clearly you're a manager.
Yeah.
But that's just playing
Yeah.
Tetris with time. That's fun.
Yeah.
And then finally, I did become a manager at ShotSpotter. And it was kind of cool. It was way cooler than I expected. I quit fighting it, and suddenly my main role
Give
in one
in to your
project.
dark side.
Yeah,
I could feel the power. If only you could feel the power of the dark side.
yes,
So you said, sorry,
relevant today. So my role there
Be a manager or be not? Hmm?
was to ask questions like, "Are you done yet? And how can I throw money at this problem to make it go faster?" And at the end of 6 months, they'd finished the project. And it was under budget and early, and everybody thought I was a genius manager. And I'm like, I could have been replaced by a little button that just said that in meetings. That wasn't like that.
Right.
Yes, but it's not the amount of force. It's the correct placement of force, right? It's,
Yeah. So it was actually more fun being a manager than I expected there, but it's not what I want to do. I like the technical track.
Yeah, well, and I mean, as a consultant, going back into consulting, then I mean, you gotta do both, right? I mean, you're just as much in charge of your time and clients' time and everybody else's time in order to get stuff actually delivered.
Yes,
So-
and I do manage my clients. Some, when are we going to have a hardware, and how is that going to lead us to a product? And just asking the right question, it provides more value than just typing on my computer, like coding.
Yeah.
There are clients who expect the consultant to actually manage the project for them,
Yes.
which, they just assume, oh, you'll take care of it, you'll handle everything. And it's like, well, that's not what you sign on for a lot of the time.
And so many consultants don't, and they don't have those skills. They have the good technical skills, but they don't. All they do is what they're told. And I feel like those clients are like toddlers in traffic. And if you get the wrong consultant, you are so hosed.
So does that mean you're like Frogger then? If you're good at that, then?
It's the same skill, yeah.
Yeah. Okay. All right.
And it's the same result when you screw up.
Yeah. Splat.
Splat.
Oh man. So what about like the range of your normal clients? I mean, so you said ShotSpotter was your old full-time job, but are you working with more like early stage companies, later stage companies, startups, experienced companies? What about those?
My broad range of skills starts to become less interesting, at least to me, if I'm working in a company that's more than 50 people. So I'd prefer to be in a very small environment because it does let me exercise some of the product and program management to say, well, what about, and then be able to push a company this way or that way. And so I like that. I occasionally will do work for a larger company, but it's usually a search and destroy or come in as a fixer for a couple of weeks to help get back on track.
Yeah.
Right.
For those out there who want to get into the field, do not take those jobs. Come in, fix it up.
It's a rigged game.
It really is.
It'll just be a week, Alicia. It's just don't worry. Just come on in.
All those noobs out there.
We'll give you a cube, and you can just come in and fix it, and it's fine.
Oh, yeah. And,
Our whole team of 10 people couldn't fix it. Now we expect you to fix it in a week.
and fixed
'Cause we're paying you.
bid for that. Yeah. New contractors don't do a fixed bid right away.
No. That can go great when you're when you know exactly what the problem is before you already get in there.
Yeah.
Yeah.
And you can milk it, and you can be the hero at the last minute. Oh, it's all going to hell, but no, you come back in. I fixed it. Look, at the 11th hour, I fixed it. I'm a genius. And you knew all along what the problem was. You were just holding off, just to appear to be the hero. That's another tip for the newbies out there who want to. Don't fix it straight away. Keep them on the line a bit. Reel them in and.
You got to make it look hard. Otherwise, why are they paying you?
Totally. Exactly.
So how much of the so like for the smaller companies then, because you write in your book as well about a lot of the system architecture and the design and stuff like that, and I think that's also interesting from because you mentioned like young people don't younger engineers don't get to necessarily do that as well.
You sound so old when you say that. Now say, get off my lawn.
Get off my lawn. I am in my third decade. I'm just saying, not for long, but wait, fourth decade. I'm in my fourth decade. I get to say that I've started my fourth decade, right? Yeah. Okay.
Yeah, you figured it out. Well done.
Right. Yeah, I'm an engineer. Anyways, so how often with these smaller companies do you get to actually do that? Like that. Do you like tear it all down and tell them like, no, you have to go back to basics and re-architect this kind of thing, or what happens there?
I don't like telling people to throw away their whole system. I don't like telling people to throw away their code. Somebody wrote this for a reason, and they had some insight that I didn't, and that I won't until I start to rewrite it. So
yeah, but even if it really, really sucks, and it's obvious that it really, really sucks.
I know, and I try never to say it, and then I eventually, 3 months later, say, "Ah, crap! I should have thrown it all away." But different clients want different things. A lot of people want me from the start, or from to do the system architecture, and then do a prototype, and then get out. Which is, it's totally fun because they want me to design their system.
Yeah, you get to do all the cool part, and you get to manufacture this. Don't worry, I'll be on to the next thing. I'll be 2 down the line.
Turn the crank and optimize. It'll be fine.
It's easy. What could possibly go wrong?
But I also do like to see things ship. So sometimes I get to see the whole cycle. And right now, one of my clients, they have a whole ton of code, and I have been trying to use their code and occasionally throwing bits out. Who uses floating point divide and interrupts? It's just wrong.
Wait for it.
Yeah. So I get to see lots of things, and I do a fair amount of system architecture because of the book and because I have a decent reputation. And last summer I worked on an IMU with a whole bunch of people that I'd worked with at a different company on an IMU. And what they wanted was, how fast can we get the basics working so that we can go back to working on algorithms? And it's a Lego project. You go to SparkFun, you buy an accelerometer, you look at the specs for all the gyros that are out.
Yeah.
So that was, it was great fun. And now they're going to productize it, but they don't. And what they want from me now is to hire their team. So sure, I can interview people. I'm good at that.
Have you read the last part of the chapters, guys?
Yeah, I interviewed at a company, and that day they had done a Google search and realized that I wrote a book, and then magically somebody had the book on their desk, and it was a team interview. They were supposed to all 5 of them interview me, and then they seemed really afraid. They were totally embarrassed to ask me questions. They were just, it was hilarious.
That would have been better if they would have just asked you one of your questions by accident.
They did say that one of their standard questions was in my book, so they were going to try something else.
Oh, darn. If you'll just turn to page 37.
Yeah.
I love it when you get to an interview and your reputation precedes you. That's always a good thing.
I don't...
Yeah.
That is never a bad thing.
No, I'm sorry. That's not true. I disagree.
No? Don't agree?
Give us the situation where it was bad.
Well, in about 2001, 2002, the episode 2 of Star Wars came out, Attack of the Clones. And I went to the premiere. It was so cool. It was a charity thing, and I got all dressed up and took a picture with Chewbacca. And for the next 6 months, every time I showed up at a new client, they had the picture of Chewbacca and wanted an explanation. So it wasn't a good reputation thing.
Darn you, Google image search!
What? So they were actually using Google image search in your name, were they?
They were just using my name, and the picture had gotten picked up by Reuters.
Right,
So,
okay.
yeah.
Yeah, because your name's not that generic, especially with that spelling.
Right.
I would expect. So
Yeah.
Right. But why
they
would
say,
they
though?
care?
Yeah,
Oh, well,
exactly.
they mostly found it funny.
And would you want to?
Oh, okay.
Well, would you want to work for a company that had a problem with that? It's like, well, screw you.
Yeah.
You know, I mean,
No, nobody was like, you can't work here if you're going to date Chewbacca.
What are you, a Wookieist?
It was just an odd way to start a technical interview.
Yeah.
we don't hire socialists, preppers, or Wookieists.
Okay, so you're gonna hire you tell people how to hire people. That's good. Obviously, you care about people coming into the field. So aside from reading your book, and maybe if there's an analog engineer that wanted to get into embedded more, what steps should a engineer take to get into the embedded field, in your opinion?
Buy an Arduino and make a robot.
Damn, too easy. All right, next question.
Well, Arduino's so cheap and it's so easy to get started with. And underneath the Arduino-ness, there's a beautiful processor. I mean, that Atmega is just a really cute little processor that I would use in products. And so if you realize, oh, wow, this is really fun, the Arduino, but, I don't have enough space, I don't have enough time, I want to get further, I'm going to buy a JTAG. And now you've got a platform to do really cool stuff.
I wouldn't have labelled it as cute.
Well, cute's kind of my generic word for good, so,
Right.
maybe that's a gender
Right.
thing.
It could be.
Adorable.
So what about processors aside from the Atmega then? Or do you have other go-tos?
It seems like everybody wants to use a Cortex M3 and something. I feel bad for
Yeah.
the Cortex
Yeah.
M0s. Everybody said they were
Yawn.
going to be like, oh, super low power. And everybody's like, no, I'll just run an M3 to lower clock rate.
We do want some MIPS after all.
You want the opportunity.
Are there any significant differences apart from that?
From the M3 and the M0s?
Yeah, the M3 to the M0s.
Some of the M0s come in a smaller package. And the M0s can't access as much flash and RAM, which is how most people get pushed up into the M3s, is they realize, oh, my
They
program
need.
is a little bigger than I thought it would be.
Then they call you and they tell you to make their code smaller. It's either I'll call you or go up to the M3, right?
Yeah.
Although at that sort of level where you've realised, oh, I need hundreds of megabytes of RAM and stuff like that, are you up into the territory of just running embedded Linux on a Raspberry Pi or something? I mean,
For hundreds of bytes? No.
at what point do you go, well, look, bugger it, I'm just going to run a complete hugely high level OS and be done with it.
That's a big jump, Dave.
Yeah. I mean, that's the difference between spending $4 on your board and spending $40 on your board. So it is a pretty big jump. And it's the difference between making it wearable and making it totally not wearable.
Yeah, but no, I'm not talking. Yeah, but you can re-engineer the board, right? Because these things are open source. You can re-engineer it. You don't have to pay for the actual board and then put shields or capes or whatever it is on top.
Yeah, but those processors are pretty expensive.
Yeah, but I'm saying if you're after hundreds of, if you need all that sort of memory, aren't you up in that sort of high horsepower area anyway? Not always, because you can, you could have like a low power data logger and you need, gigabytes of login memory or something. But
No.
I'm just talking a bit
No,
generically.
the little processors still do a lot of stuff. I mean,
Yeah.
this is some bias because I kind of like embedded Linux, but if I have my choice, I will rip out any RTOS. I mean, my book actually doesn't cover an RTOS at all because I prefer to go bare metal or with a little dinky scheduler message passer.
But what if you've got a user interface? What if you've got a touchscreen GUI interface and you're talking to SD, saving to, SD cards and drives and networking and doing all sorts of that? Surely you wouldn't do that from scratch.
Oh, no, probably not. But there are Cortex M3 TCP/IP libraries that go on a number of different RTOSes. So SD cards, you can spy to them if you're willing to, and
oh yeah, that's pretty easy.
Trivial. Yep. And user interfaces. As long as it's still got pixels, you're fine.
Yeah. Yeah, if you're not driving like a OLED or something crazy, right?
Right.
Or even if you are, you can offload it sometimes.
Color OLED, yeah, those are a bit much. But there is also offloading it. And my favorite processors, I do have to shout out to the TI C2000 line, because I have loved that line for as long as at least 10 years, maybe 15. And it's still around in the Delfino and Piccolo variants.
Yeah.
And it's just,
And why, shall we ask?
Because anytime I'm using it, I'm doing something neat and mathy. And I like math.
Yeah. Motor stuff, you use it for motors as well?
I'm using Piccolos for motors now, and we used the original C2000s on the inertial measurement unit, audio processing for some projects.
But how is it better than something else for the task? Or is it just because you did a cool project and that happened to be the processor you used, so therefore that processor is cool?
No,
is that...
It's a DSP, so it's got special goodies for doing FFTs fast. And so Fourier domain stuff.
That's cool. Yep.
You're not going to get that on a Cortex M3.
No, typically, you might have a FPGA or a DSP co-processor or something like that to do that sort of heavy lifting.
I mean, I guess that kind of gives us an idea of some of the realms of stuff you're doing with the DSP type stuff. I mean, what would you say percentage-wise in terms of like size of code base and size of, I guess, not really size, but like horsepower of processor? Where are you mostly operating with?
Under 60 megahertz or 60 megahertz and below. If I see a half meg of RAM, I have no idea what to do with it. That is so much. Oh my God.
Yeah, right.
So I guess I'll put some MP3s in there or something.
Totally going to make this thing run steady at home.
Yeah, exactly.
I'll make this into a space heater by just crunching numbers.
And
Bitcoin mining, yeah.
and a half meg of flash. That would be a lot for me to fill with code. I could just have jump tables everywhere.
Well, it pretty much is for the embedded systems you're talking about that don't run a really high-level OS, I mean, if you're just sort of, doing your own thing at the bare metal sort of level, then, a few hundred kilobytes is a ton of flash,
Well, and if you need to respond really quickly, I mean, the robotics is a good one.
Yeah.
We don't have an RTOS because the RTOS's latency just isn't worth it to us. A lot of the audio and visual effects, you have to be at least aware of what your RTOS is doing.
Well, and there's always that weird trade-off too with like real-time stuff. Like if you need tons of processing, you're gonna probably offload it anyways, right? Like an FPGA, like Dave said, do some kind of streaming type thing if you really, really need it. And if you need to be small, then like the RTOS kind of fits in that middle ground, right? I mean, somewhere between the two.
Yeah.
I always think you have to go RTOS when you start doing stacks. Anytime I hear stack, and I'm like, got to throw RTOS in there.
TCP/IP stack must need RTOS. Bluetooth stack might need RTOS.
Unless you offload it, which is so much easier.
And then you start offloading your code to the system on a chip, and then suddenly you don't have a processor anymore.
Mm-hmm. That's right, exactly. And then I call you, and I just make you do the whole thing anyways, right? It's just, this is easy. Dave, let's go get funding and make something and call Alicia to make it for us.
Are you a fan of multi-processor solutions, like throwing a little 30-cent micro over there just to do that one little task? Bugger off, I'm going to, or do you like the one processor to rule them all?
That's a good question. So I have been using.
That's why I asked it. See, Chris, this is how it's done.
Don't be an ass, Dave.
So I've been seeing a lot of small coprocessors, small cheap coprocessors that are super low power, that essentially handle the minimum amount you can do with a UI and then wake up the big processor whenever they actually need stuff. And I like that. It's not my first go-to solution because of compilers. And this is probably a rant that you don't want me to get into, but
no, bring it on. Come on,
we want it. We
love
want it.
Embedded compilers are just not as good as I want them to be, and they're so freaking expensive.
Yep.
And
you're talking like third-party tools, right? Not the ones that come shipped with like, oh, you get 64K, right?
Well, they're not as expensive as
and
they
they're
were
better,
when I was a boy.
But man, eventually, sometimes I use Microsoft Visual Studio, and I hate using it because it makes me feel all dirty. But
cheap and dirty, yeah.
But then I use it as I'll debug with it. I'm like, oh, this is so nice. I can see all the variables real. I can have as many breakpoints as I want. It does smart things. I can have tracebacks and like go back but on embedded compilers, you're lucky to get 1, maybe 2 breakpoints. And I understand the hardware limitations of all that, but still. And they're buggy and they crash. And so if you're talking about a 2-processor solution, don't forget that means 2 different compilers probably.
2 different tool chains and everything else.
And they don't talk to each other either, right?
Yep.
Unless, well, even if you had 2 in the same family, right? If you use the same processor twice, you'd still need 2 separate ones, right? There's no way to do like debugging on both at the same time. Right?
Oh, I can sometimes debug both at the same time, especially if you use virtual machines to do some of your debugging.
Okay.
And my partner and husband, Chris, is like a big, you must use VMs on all client stuff because it's so much better, and then I just disobey.
And then
I've never used a virtual machine,
Well, then when you're frantically trying to recover something, he just clicks a button and it's back
and he
up,
laughs.
right?
Yes. Yeah. It's great.
Yeah, but he would.
Right.
So you can dual debug even without VMs. You can dual debug using 2 JTAG modules. But why use 2 of the same processor? At that point, just double the speed, clock speed, or whatever was you needed.
Yeah.
But if you're doing a 30-cent MSP 430 and a $3 Cortex, then those are different chains. You're not even talking to the same thing.
Yeah, totally. But you often don't have to debug them at the same time, because the reason that you would, to begin with, to actually make that decision to separate them out, that task out, means that it's a totally independent, verifiable task, and you don't have to debug them at the same time.
But you still have to buy both compilers.
Yeah. But these cheap micros, you don't have to buy the compilers for them. I mean, if you're talking about the PICs, if you're talking about the Atmels and the ones like that, the 30-cent micros, there's free compilers aplenty.
There is some mental cost. I mean, they're fun, so I'm not really going to complain about learning new stuff.
Yeah.
But if you are running a team of 3 or 4 people and you want them to be able to go back and forth between them, it's just one damn more thing to do.
Yeah.
Yeah, well, that's how I always think about these little processors are great for offloading tasks, but I always think about like managing firmware as well. Like I've actually rejected like a lot of the, like, again, I bring this same damn chip up we've been talking about for the last 4 weeks, but like these ADU-CM 350, 360 ones from ADI, which are like these awesome all-in-one chips, but then it's like I don't want to write code for that. I don't want to have to manage that stuff. I'd rather have one main guy that's talking SPI, even if it's a little bit slower or something like that, and then not have to have a second firmware image, because then what happens if it's out in the field and you and you find a bug? You're screwed, right?
Usually one of the processors has to pass the code to the other processor. Please don't lose power during that time. And you can design good bootloaders for passing code around, but it just is one more thing to go wrong.
You could put in a self-destruct if it doesn't actually update properly, right? The whole board just explodes. It'd probably be easier.
You were
and
joking,
faster.
but I've worked on military devices, so yeah.
Me too. I've designed a product that actually scuttles itself to the bottom of the ocean after X amount of hours.
That is awesome.
It actually,
Mine just, quietly self-destructed the chip. There wasn't even smoke.
self-destructed in what way? It just overwrites its own program memory?
Yeah,
or what?
overwrites its own program memory. Loads itself into, loads its little bit into RAM and then flashes the memory a few hundred times.
Well, if you did it a few, like 10,000 times, bang, it'd just wear itself out.
I did it until its batteries died.
All right.
I mean, if you're trying to destroy something, you might as well continue until you're done.
Yeah, right.
Yeah, exactly. Go for broke.
All that charge is sitting there waiting to break something. So it's just yeah. So what about the dealing with like all the firmware side of things and the updating and like updates? Like, I mean, is that a large part of your task as well? Is kind of thinking about strategies for that?
Well, there aren't that many different strategies for it, but yeah, and being a little bit paranoid helps because there's always the chance you're going to brick your unit and totally make it non-functional. So yes, absolutely. That is one of the harder firmware tasks, I think. Making the robot go is not as hard as making the robot go after you've changed your mind about what it was supposed to do in the first place.
I like that, yeah. What about making the robot go to sleep and not waste his batteries?
Power optimization. I like power optimization now.
I know, it's sexy, isn't it?
It is.
I like it.
Because, I did all this optimization fairly early in my career, learning how to put things small and make them fast and just optimization because the processors weren't big enough to do all the stuff we wanted to do. And now it's all coming back in power optimization because you still have to be small and slow or fast. And sometimes you run the clock speed differently so that you can just eke out a little bit more or a little bit less power. Yes, I love that. What was the question?
There wasn't one really. I just said, robots need to shut down and sleep sometimes. But it's interesting because it felt like, I don't know, I haven't been around that long, I guess, but it feels like this shouldn't be a problem anymore, right? It's like, oh, well, things keep getting lower power, the transistors keep getting smaller and there's less consumption there. And yet, yeah, this stuff is still like a really big deal. I mean, like trying to find ways to save battery life and make devices last longer. You'd think batteries haven't gotten any better, so that's not helping. But
well, you mentioned last week that I worked on something like Fitbit, and I will correct you on that. I worked for Fitbit when they were about 20 people and 3 firmware engineers, and now they're like 20 firmware engineers and a lot more people.
Oh wow!
So I don't work as much with them. I work a little bit with them sometimes, but just maintenance stuff.
Are they all fixing your stuff now? Is that kind of the idea?
No,
you get to do the
they're
architecture.
working on fantastic new products, and I wish them all the best. And I'm excited for when those products get announced because I don't have to remember not to say anything.
Yeah, right.
But that's a power optimization problem. I mean, tiny battery, bright screen. Things that need to always be on and doing something, and yet sucking as little power as possible. That was fun. I mean, robots are a little harder to go to sleep, not because there's any real difference, but because they have to be connected to some large power source anyway. So why bother?
Right. Yeah. If you're cranking amps through a motor, who gives a shit about
milliamps?
Excuse me. Milliamps. It's like, okay, well, though I guess it's a little warmer now. No big deal.
Yeah, but you can't just go pissing away a couple of milliamps here and there willy nilly. You've got to,
You can.
No.
If you're using wall power, everybody does it.
Yeah.
Well, that's
I
no
agree with
reason
that.
to do it because everybody else does it. Everybody else is jumping off the bridge. I'm going to do it too.
I don't know. I'm totally with Elle on this one.
No,
I mean,
no.
If you have a power cord, if you're dealing with all the crap you have to deal with having a power cord coming out of it, you might as well take advantage and not worry as much about the power stuff.
No, I kind of agree with Dave actually, because it is a fail. I mean, you're destroying the environment with your milliamps all the time. But from an engineering perspective,
wait a second. Wait a second. Dave loves test equipment, and having worked on test equipment, I will say that the digital sections help to heat up the analog components and stabilize the temperature. How about that?
Says the analog engineer.
That's right. You need stable temperatures. The faster it gets to 80°C, the better.
Analog, when in doubt, throw heat at the problem, you know? That's... Oh, yep. God.
So what? I mean, so what do you do in that case then? So you like shut things down, or you do like sleep cycles, or how are you doing that?
Well, processor dependent, but sleep cycles. We PLL the clock so that you only have to put in 8 megahertz or sometimes even 3 megahertz to get up to a 30 megahertz clock. And so you turn your PLL down, and now you're drawing much less power. Or many processors have actual sleep instructions, and they wake up for a limited number of interrupts. So you design your system so that important interrupts are on those interrupts. And when you need to wake up and do something, you do it as fast as possible so you can go back to sleep, which is kind of how I do engineering, really. I'm kind of lazy until I can't
I love the processors that have little dedicated hardware things in them. Like they'll have you won't have to run the processor at all. Like it'll have an analog to digital converter that just works on its own, takes a measurement, wakes up, just the ADC part wakes up, takes on a timer, takes a measurement and goes back to sleep and stores it without the actual processor waking up. I love those.
And then it wakes your processor up when your FIFO's full. That's just brilliant. That's how it should work.
Yeah, I know.
I totally agree.
I know. It's great.
Yes.
Awesomeness.
Which processor are you talking about?
Oh, there's lots of them. Almost most families will have, the Atmels do it somewhere. The microchip PICs definitely do it, and I think the Renesas ones do, and quite a few.
TIs do it too.
Yeah,
that's what I was thinking of.
Right.
Okay.
No shortage of them.
I just wanted to know if there were other processors I should be playing with.
There's countless ones. I mean, geez, it's almost too hard to make a choice. Starting a new project. Oh, what processor am I going to use? That's why most engineers just work with one they've worked with before, because, well, even if it's not the most optimum solution, because they're familiar with it, and that's a perfectly valid.
It's not a bad solution.
Yeah, exactly.
Yeah. Well, and then I go back
because
to I have all the tools and I know how to use them. Because it's often more important
to get the project finished. Well, exactly.
Yeah.
At the end of the day, engineering is getting a job done by a certain amount of time at a certain budget, right? With a certain amount of resources. That's engineering. Otherwise, you're just mucking around. Otherwise, it's just hobby.
Oh, getting things done?
Yeah.
I think everybody at some point in their career should really think about working for a consumer product, because seeing my products on Target's shelves was so addictive to getting things out.
Right, yes.
Totally made me want to just ship it. Whatever it was, ship it, because I want to go to Target and see it.
Right.
Yeah.
See, I worked at the other end of the spectrum where most of the projects I've worked on in my career have been shit-canned. They've been cancelled before they actually shipped. And, that could be a bit demoralising.
I was one of the reasons I left Leapfrog is they canceled my toy line. And I was like, yeah, why am I here? I'm not going to wait for next year's toy line.
Right.
Give me some really complicated toy. And I like the little ones. Yeah.
With fur on them, preferably. Little cuddly furry toy that talks back to you or something. Come on, that's... Oh, boy.
So Leapfrog is that's the main ones that we would have seen on the shelf. Any other shelf-based things that we would have seen of yours?
Well, Fitbits are on the shelves. I worked on the One and a little bit on the Flex and Force. I'm trying to remember their real names, not their code names.
Right.
And the Aria Scale. So those are all currently on the shelves. My Fitbit or my Leapfrog toys, none of them were on the shelves at Toys R Us today, but some of them had my code in them, which
Cool.
was fun because I got to go play with those. And
Did you program like backdoors like Jerry did with like fart noises and stuff, or do you do anything fun like that?
Yes. Well, no, there was one toy that everybody hated, and I did an Easter egg for that one that ended up being very cute, and cute in the really adorably cute real way, not in my normal cute. But everybody, it was a toy. Violet is out now for Leapfrog, and you can add your own voice to it. So if you're giving it to your kid and you want it to say "Mommy loves you," but in your voice,
right?
Oh,
and
creepy.
And so we were doing that like 10 years ago, and it was kind of a beast because we were recording and playing back, and there were robotics involved and blah blah blah. And I totally forgot what I was going to say.
Please tell me that you've embedded a Yoda voice in there somewhere. That'd be awesome. Do your homework, you will.
The Easter egg.
Yeah, Easter egg.
Right.
So if you push the buttons in the right order, it would say everybody's name as though it was Romper Room, and everybody came over to my house and recorded them saying their own name. And so it was this kind of mini tribute to the 15 people who had worked on this toy.
Oh, nice.
And it was really, I mean, people would play it for their friends, and it was clearly you saying your name, and it was a good Easter egg. And
that is a good Easter egg.
It was a happy Easter egg. I think it made people hate the product less. I mean, not the final customers, because they never knew about it, but the people who were working on it, who were all demoralized. It was better.
Why was it so shitty? Was it a bad idea? Was it bad management at the time, or?
No, it was 6 good ideas all smacked together
to create a fail. Yeah.
And there were Leapfrog was one of the first companies that put the whole alphabet on a toy. Before Leapfrog came around, Fisher Price would have these little buses, and it would say A, B, C, D, E, F. And then it would just stop, as though that was all you ever needed to know.
Bunch of kids walking around not knowing their alphabet because of that.
Because, it was kind of educational.
Right.
But Leapfrog would put the whole alphabet on, except their infant and preschool line, sometimes they would put the whole alphabet on the chest, and it made it hard and uncuddly. And many of us wanted this particular Mommy Loves You toy to be super cuddly. And with the alphabet on the front, I think that was the deal breaker. Is that we didn't want the whole alphabet. We should have just had a couple of glowy bits, or the triangle square thing they do sometimes.
Yeah.
Right.
I'm always interested with the whole toy industry side of things. Like, so I've talked to obviously you've been in the toy industry, Jerry's been in the toy industry, Todd Bailey, an analog/embedded guy. I've never had any personal experience with it. It sounds like it's like this awesome gauntlet of like fast release, like you mentioned, but then the thing that I don't understand is like I would hate to think about all these things I worked on just like sitting in a toy box somewhere. So is there any of that, or is it like, no, there's just too many other problems to worry about?
Oh, you mean that it's going to go to waste?
Yeah, like it seems like these really elegant, like fast solutions, right? I mean, like these elegant uses of constrained resources, and then it's like, oh, and the chump company in China didn't really make it right, or like it's just like you could do everything right, and there's still a lot that can go wrong.
You're a pessimist. I didn't know that. You always sound like an optimist.
It's the happy tone of my voice. It's really the Ohio accent. Yeah.
Yes, of course. And I have been to yard sales and seen my toys being yard saled, which is kind of depressing. But I also worked at Leapfrog would let me take like a half day off to go help in a kindergarten. And I took some of my toys, one of which was the most freaking annoying karaoke. You were supposed to sing along to it and voice change. But it was, it was a karaoke. It was horrible. And this little boy didn't know his alphabet when he got to kindergarten, which I guess now is you're supposed to.
Yeah.
And he was falling way behind, and the teacher was just kind of depressed about it. And I played with lots of the kids, And he took the karaoke home with my permission. And a week later, he knew his alphabet and he was catching up to class. So
Awesome.
It goes, yeah, I'm sure my toys ended up being used for 10 minutes and then thrown away. And that makes me feel bad. But a couple of the kids learned something. So I'm ahead. I'm fine.
Yeah. No, that is, and that's true. And I mean, I guess you weren't making like G.I. Joe, like sound activation type stuff either. Right. So that's good. That the educational side, I'm sure, helps a lot there. You know, that is really cool.
Well, and before that, I'd worked on bombs. So, you know, it was a big win.
It can always be
bombs,
worse. It can be choker chicken, you know.
What?
Yeah, haven't seen those choker chicken toys that you can buy at your local electronics store? They sell them here. It's a chicken and you choke it and it squawks. When you choke it. I mean, that's... And there's a whole spin-off line. There's actually Choker Boss. So, like, it's your boss, you know, so you choke it. Oh, I hate my boss. And you choke it and it screams out. Ah! You know, I mean, it's just ridiculous toys like that. All those farty novelty toys. All these Spankometer we've talked about before.
Wow. So Australia's weird.
I can't believe they must sell these things in the US. Come on, they have to.
That and big spiders, right? Yeah.
Oh boy.
So okay. So how about this question? I already asked about how an analog guy could learn more about embedded. What are some of the big mistakes you're seeing over and over again? Either not necessarily when you walk into a client, but just like overall, what are some big mistakes you see or big misconceptions you see when people are jumping into embedded?
People think that because it runs on Java in my browser window, it should easily be able to run on my embedded platform. And people say things like, well, we had the Game Boy you know, a long time ago. This isn't more complicated than a Game Boy. Those poor Game Boy developers like assembly coded their stuff.
Yeah.
Oh my God, really?
I mean, they tuned, and it's impressive.
Yeah.
Yeah.
Or people who are like, my iPhone can do this. Why can't your $5 device do it? Like, to hell with you. Your iPhone, you have any idea how much that puppy really costs?
Yeah. It's $600 on a good day, and that's because Apple probably, you know, holding down people and had a gun to their head to get the pricing. You know?
Yeah. And so why do you expect your pocket device to do what your iPhone does when you're willing to pay sub $20? That's silly. But I see a lot of that. Did you mean product things like this, or did you mean more like what do I see engineers do?
Yeah, well, kind of both. I mean, I'm interested in all this stuff, really. I mean, I was really looking at you know, chapter 4 and 5 and thinking about how crappy I am at like interrupts and stuff like that, and seeing how people thinking about how people do that wrong, like interrupts wrong and state machines and all that, all like the more in-depth stuff, like how you see those being implemented wrong.
I mentioned the floating point division in an interrupt. Yeah, that will always, man.
I think dividing in general is usually pretty bad, right?
Yes. Yes,
have, like,
and when you
DSP
type
on board.
wait millisecond in an interrupt, you're doing it wrong. Just a clue.
Yeah.
I guess one of the things that if you're at that cusp of, I think I'm doing all the right things, but my stuff isn't getting better, don't be afraid of opening up the assembly with the C code, especially if you can walk through it, and see which instructions take a long time. In C, every instruction takes a line, right? I mean, you actually can pile in a couple dozen lines on there, a couple of go-to fails too. But when you open up the assembly, you can see how long a divide takes. When you do a floating point divide, oh look, there's a whole library out there, and it takes a couple more hundred instructions. So I think that's something people can do to get much better. And it really helps figure out, well, why does my interrupt take so long?
Did you get started doing assembly, or did you start at C?
I started at C, and now I am fluent in TI assembly most, and I can read ARM assembly happily and write, the boot part, but I won't write a whole lot more in ARM assembly unless I really have to. I've had a couple of clients who wanted something to go much faster and wanted me to rewrite it in assembly. And what I did with that was actually, I ended up giving them back a C file because I would read the assembly and then I would tweak the C to tell the compiler what I wanted to do. And that's a really good way to optimize, because in the end you end up with code that is readable. And as long as you have lots of notes that say, don't screw with this, don't change it, or if you change it, at least look at, don't do a freaking floating point divide in this interrupt. I'm only a little bitter.
Really gets you going, huh?
So
no, that's good. No, so I mean, I always wonder about that, if I should go back and learn assembly and stuff like that. I mean, my C is pretty piss poor to start with, but I worked with like a really, really good, experienced embedded engineer at my last job, and I tell you, like, I will never be at the level he's at. I don't think, because he's so deep in the compiler, and he would run those comparisons to see what would be faster and slower, and he would talk about everything in clock cycles and that kind of thing. But I just wonder, I was wondering about that with how much you do need to know about under the hood stuff, because I think for a lot of people, they don't even realize that C still has a lot of under the hood, right?
It does.
Like instruction sets and all that other crap that...
Well, it's a compiler. I mean, it's not a high-level interpreter. It compiles to machine code. I mean, well, it compiles to assembler, and then the assembler converts it into machine code. I mean, it's,
But I wouldn't learn assembly directly. I would look at what your C is doing and learn assembly that way.
Yeah.
Because the assembly languages still are changing, strangely.
Really?
Yeah.
Just because of instruction set and everything else? I mean, like RISC versus CISC and all that kind of crap?
Oh, and then the processor people come up with fancy new things to do and realize they need this or that. And it's easier just to let the compiler do it. And if you need to optimize something, I don't suggest going and optimizing it by hand. Turn up the compiler. The compiler will do a better job than you will. It'll make it hard to debug, but don't torture yourself.
Well, yeah, it's like a diminishing returns kind of thing, right? If you sit there all day and you have it perfectly, you can debug it really well, but your time is all spent up front. You don't have to spend any time in the back end then.
And if you're optimizing, if you have to hand optimize the assembler to tweak every last cycle out of your processor, then you've probably chosen the wrong processor, because you haven't catered for, expansion. You've probably made the wrong choice somewhere along the line, I think, in terms of either processor, clock speed, or resources, something else.
Given how fast the processors get cheaper, I agree. I mean, I have optimized if somebody says we really want this processor right now, but it is a little easier to just wait 6 months.
Yeah, exactly. I mean, I can remember having a pick back when picks were, fairly expensive. So it was a big choice to choose the next one up that had 2K flash memory instead of 1K,
Yeah.
So I would hand code my entire thing in assembler, and, it had 1K of memory in it, and I used 1,023 bytes or something. I just fitted my entire application in with a couple of bytes to spare, and it was just stupid, because it didn't allow me to expand. If I want to add, a couple extra lines. Oops, I can't, because I've used every last byte of my memory. If you're making $1 million, yes, it can matter. It can matter.
15 cents matters a lot. 15 cents is so much more than your salary right now. Go save me some money. How come I don't get any of this money?
Yeah, right.
Oh,
I think because at that point you'd have people, designing in extra stuff at the beginning, and be like, "Oh, hey, boss, I
just wrote myself a new
$3 million." What about that? So from the resource perspective and like where you get in on projects, I mean, do you have a lot of exposure to pricing when are you helping with that kind of stuff?
Not really, no. I mean, I keep track of the DigiKey 1K cost of some processors and some components that I like, but no, I can make suggestions, but the companies I've been working with lately either didn't care that much about prices or had a whole team to do it. Definitely.
And then you would have forces changed upon you would have choices forced upon you in those cases where
A/B choices.
Right. Okay.
It's sometimes how much would you cry if I change it to this?
Right.
Choices.
Yes.
Not
I've
just
had that
phrased that way.
conversation many times. Yeah.
More like, what features are we going to have to give up if I give you the lower flash processor?
Yes.
And
then the sometimes the correct answer to that, somebody coming up and asking you that question is, I won't cry, I will stab you with this hot soldering iron.
Right in the face.
That's it. Oh, goodness.
What about what I think Dan Sachs has made his career on? What's your feeling C versus C++? Because I always see, whenever I see Dan Sachs giving a talk, it always seems to involve C and C++.
C++ is
side
for
by side.
new age pansies, you know.
Okay.
I don't know, I'm just throwing it out there.
C++ is really useful if you are doing a user interface that involves tiling or moving things around or windows. That's an area that I would just put my foot down and say, we're using C++ because that's the way to do it. No other area has that level of my way or the highway, but I use C, I use C++. They're different. I don't think they're as different for me as they are for some people because I believe in object-oriented all the time. Modules should be encapsulated. They should have limited access points and they should be testable. And so my modules look like C++ classes, whether or not they say class or whether they just have good names. So I'm not as bugged about that.
So where's the limitation with that on C then? You'll have to excuse my long-term C++ lack of knowledge. But where is the limit then? If you set up all C like that, when do you run into a problem there? Is it like when you're
inheritance?
It's just that you can't do classes? Okay. Right.
You can make classes look like other classes, but unless you're casting things, they can't just be and inherit other classes. You can do some interesting things with structures and function pointers. So I'm not going to say never, but then it starts getting really complicated and why don't you just go ahead and use C++. Yeah. So
I think I'm going to get myself a T-shirt that says "Global Variables all the way."
Memory's cheap.
Global Variables for the win. Yep.
What could possibly go wrong with that plan?
Yeah, just you just have to be really good at naming stuff, right?
Inheritance, polymorphism, and all this sort of new
Signal
age garbage.
1.
Yeah.
Signal 2.
When I was a boy.
It takes so long to type signal. You should just make them S1 and S2.
Right. Oh,
there you go. Yeah.
Right. Real meaningful labels. Yeah.
You know, once you hit 64,000 or so, you could probably switch to a different letter or something, you know?
Yeah. Well, and since comments slow down the code so much, you really shouldn't have any of those.
Yeah, right. Yeah.
Yeah. Do you participate in the obfuscated C contest at all, or is that
Not intentionally,
not
no.
logical elegance?
Not for any reason, just because I have to untangle these things too often. I don't need to make more knots.
Yeah.
Have
you take my work home with me?
Have you ever worked at a company where they tell you not to comment stuff? Because I have. I'm just curious.
I've had discussions with other developers who believe in self-commenting code, and I don't entirely disagree that your variable names and what you're doing should be readable. And I definitely want that of my code. But the comment is it's like another channel. Like, in meetings sometimes, well, maybe you don't, but in meetings sometimes the engineers will type at each other through some sort of IM or chat message system. And so you get both the meeting and the back chat. And so I kind of think of the code and the comments as the meeting and the back chat. And my comments, I try to make them funny or make them story-like or make them engaging so that you do want to read the code instead of trashing it and writing your own, which a lot of times it's easier to rewrite than to read.
I can just picture it now. Variable X loves variable Y so much that it instantiates over here and then joins. Oh, goodness.
Variable X, oh variable X, wherefore art thou, oh variable X?
Well, I've worked at a company where, the opinion was that commenting was a waste of time. If you were spending money typing comments, that's spending time typing comments, that's less time you can spend typing code. And
less time you can bill for troubleshooting.
Right. And, they get everything they deserve, I guess.
Yeah. I mean, did they never want to reuse that code? It was just throwaway code?
No, this is actual product code. Yep. No, this is reusable. Yep.
I wouldn't want to debug
that. Sounds like a manager thing.
Yeah, it's a total, yep. Anyway, let's not go there.
I've heard people say they don't want comments because they get out of sync and they're not maintainable. But if your comment is delay microsecond 10 / wait 0.1 millisecond, that's going to get out of sync, and why bother with the comment?
Yeah,
right.
And there are those useless comments where it's like, it'll be, X plus Y, and the comment will be add X plus Y. It's like, hello. It's like, you wasted time telling me that.
I think the people who say don't comment anything see only those comments and fail to see the...
Right, yeah.
We're adding X and Y because.
Because,
yes.
Because part, yep. Oh, there's also those people who are of the opinion that thou shall leave, a commandment, thou shall leave no dead code, as in, or no commented out code. You should totally, if you're going to comment out that code, then
delete it.
You should then delete it. You're in that camp.
Delete that code and use your version control system to pick it back up if you need it.
Right.
Do not leave me code that is just randomly commented out so that when I come up to your code base and need to make a change, I have to grep through all of these lines that don't even exist and then try to figure out why you commented out if that's where my bug is that you accidentally left this. No.
But what if you documented and commented? But what if you documented and commented why you commented it out?
No one does that.
Version control.
This newfangled stuff. I don't know.
So what if someone comments out the robot code? The robot code that says "Do not kill human."
Yeah, right. The Asimov laws. Yeah.
With a little comment that says "Wanted to murder my wife."
Yeah. Oops! Did I leave that in there? Don't tell the lawyer. So what about version control? Because if I think you corrected me on this when I was on your show, but I seem to recall you saying you hated GitHub or Git or something.
I'm not a fan of Git, but I'm not a fan of Git in a specific environment. I worked with a company they were expert SVN users, and they wanted to try Git because it was the newfangled cool thing. And
well, that's stupid.
Yeah, and then they all tried it in a different way, and there was no process. Everybody was trying their own thing. Some people were rebasing, some people were branching here, and some people were branching off there, and it was very disorganized and crazy. And I realize now that I was confused by their stupid processes, not by Git itself. And I think if I went back to use Git, I would use the command line. Somebody told me that was the key, is you have to learn the command line before you can use the Torty SVN or Torty Git interface.
Torty?
Yeah.
Tortoise. Yeah. Sorry. Tortoise.
Sorry, that might be a difference.
Yeah, it's that's the big jump I made too. Is I did GUI for a while, and then when I actually needed to do anything useful, that's when, you got to jump to command line eventually. They also told me, the friend who was helping me is like, there's about 100 different ways to do everything.
Yeah.
So
Right.
you can kind of screw yourself.
And I don't like that. I kind of want there to be just one way to do everything.
Yeah, me too. Totally. Just like choosing a bloody processor, I want there to be just one choice, so I don't have to make it.
Yeah, right. You know that Dave would make a video as soon as someone said you can only use one video. Oh, and then they told me I couldn't use this processor, and I have all these thoughts about this. And
I long for the days when you had to do everything in 7400 series logic, because that's all you damn well had. You know?
Yeah, right.
Now it's Dave's turn to say, "Get off my lawn."
That's right. Yeah, exactly.
Get off my podcast. Oh dear.
So what in embedded? What do you think's coming up? I mean, what do you think? What excites you about embedded in the near future? Is it robots? Is it quadcopters? Is it others? I mean, what's most exciting to you?
The latest processor, because the application almost doesn't. The applications are infinite, aren't they?
Oh, I'm way more application oriented than processor oriented.
Ah, okay.
Processors are a tool to get from here to there.
Oh, no, they're an end unto themselves. Trust me.
It's just a hardware engineer.
Nerd.
Yeah, says the guy who doesn't like writing code.
Hey, I like writing code.
Every time you write code, you're like, and I know people are going to complain about it.
Yes, because they do, because they hate my coding style. Shut up about it. I didn't do computer science. I went to the School of Hard Knocks coding. Thank you very much.
Comment stuff out. Applications.
Sorry.
Applications.
I think so. We're seeing lots of LED neat things happening, and we're seeing lots of neat wearables. And I think that power is going to be interesting. You know, Microgen is making their power generator using vibration. I think that's super cool, and I'm like anxiously awaiting their dev kit. But for applications, I want feedback. I want touch feedback. I want something that can tell when I'm touching it, and I want it to, whether it's little actuators, little spinny motors, little vibration motors, little needles, well, not pointy needles, but something that I can, you could send me a board and I could see what it was like really physically see what it would look like on a 3D, not printer, but something temporary that acts. And then if I wanted to have an online, Tamagotchi sort of pet, it would actually give me the petting, purring sensation. And it would be a size, maybe a touchpad initially, but it would get bigger until it was bigger than my iPad, and it would plug into my iPad, and there'd be all sorts of games that involved me tactily having haptic feedback. So that's what I want next.
What you want is an iPad connected choker chicken. I'm telling you.
Dave, no, don't go there, man.
Dude, I'm telling you, it's the bomb. Okay.
So after the show, we're going to tweet Dave likes choking a chicken.
Just make sure there's no context. That'd be great.
Yeah. So wait, do you mean like having like a pair of gloves on and like putting them into like a virtual plane, like a leap motion type plane? Do you mean like that? And then the gloves give you feedback?
Well, okay, so
I'm not sure I
so
understand
say
that.
there are, let's go with gloves, because that's definitely one way to do it.
Okay.
Say the gloves have 512 individually accessible, individually addressable coin cell style motors.
Of course, it has to be a binary multiple like that. It's important.
Yeah.
And
just pointing that out.
Now it can vibrate the tip of your finger or just below or the back of your finger or the front. And so if you want to make it feel like you just stuck your hand in 7-Up, you wouldn't get the chilly part, but you would get the fizzy part. And if you wanted to feel like you were touching the Empire State Building, then it would actuate so that your fingers would have a hard part and a soft part, and you could touch. You could touch things you can't touch. It's the next. I mean, it's virtual reality. For your
why don't you just touch the real thing? I'm sorry, I call me old-fashioned, but
You gonna get on a plane for 17 hours, Dave?
So coin cell motors are big. If you start thinking about tiny motors, tiny, size of, say, 1 millimeter by 1 millimeter, that's still kind of big, but that's much tinier. And now, what if you could put VR glasses on and hold the board that you're about to design and be able to put it into, visually, the system you're about to design and make sure those tolerances are what you think they are? There's something about holding something that's better than visualizing it on the screen. And I mean, I'm kind of putting it towards technology, but think about games. Being able to play ping pong with somebody who's across the country with your palm.
That'd be cool. Yeah, that's...
I'm waiting for haptics.
So is that possible? I've never.
Yeah, of course it is.
So what's it like? A coin cell motor is just a tiny motor running off a coin cell. Is that the idea?
No, a coin cell motor is the motors that are the size of coin cells, batteries. They're used in pagers, cell phones.
Oh, okay, yeah. I see. The ones that actually buzz when you do like a haptic feedback, like you're talking about, right?
Yeah, they're the vibrators in your mobile phones. You know, those kind of little tiny motors. Yeah.
But now I want something much smaller and probably with more memory.
You want nano
wire.
motors, and there's work going on those.
Mm-hmm.
That's cool.
Yeah.
So.
Well, good. Yeah, I'd like that too. That'd be cool. I'll take one of those.
Yeah, but you
Kickstarter.
Totally.
This is all we need, right? We have a plan. All we know, Dave can make a video. It'll be fun.
Yeah, gotta make a video.
Yep.
Nothing.
Yeah. We're looking to raise $1.7 billion.
Exactly.
We want to hire DARPA. We want to hire DARPA.
So I'm not working on anything like that. That's just the big next application that I want to see has to do with a lot of the force feedback and haptic sensors, which goes really well with the VR systems that are coming out.
Yeah. Oh, yeah. Like Jerry and like the Oculus. And a bunch of others. Yeah. Yeah, that'd be really cool. I don't really do games, but I think every time I see a game application like that, I always think, how can that be used for CAD? That always seems like the first thing my mind jumps to.
I'm playing this game Threes on my iPad, and it involves adding up threes to make Tetris-like things, and it's algorithmic, and it's so good. But my thought is, this is totally the part of my brain that loves coding, and it's doing this. And so there should be some application. But I don't know what it is.
Like add up threes and it does like a nuclear launch code or something? Or
No, like add up threes in order to, like, behind it should be hiding, like, doing layout on a board. And it's like playing Tetris should be actually doing layout on a board, but the interface I see is Tetris, but it's going to do something more useful with my time than playing stupid games.
Right.
Doing layout on a board is like playing Tetris. You can just go do layout on a board. Maybe you just need to find the right CAD program. That's all I'm saying.
Yeah, I hear KiCad is what I should try.
It's the new hotness.
There's even a class about it.
Yeah, oh yeah. Wow. There's even an interview on an embedded podcast, someone talking all about a class about KiCad.
Yeah.
And he won't shut up.
I think so. I think there is.
Yeah.
Yeah. We'll have to look for that.
Gracious.
Dave's jealous he didn't come on my podcast.
Oh, I'm sure he would if you asked nice enough. He's so busy. He's busy.
Do we have any listener questions?
I lost them.
We're so professional here on the Amp Hour.
Yeah, I have more questions myself, so I'm going to ask questions anyways. So what about writing a book? I mean, is that hard? Because this is
No, it's easy. You spend like an hour a day, you drink your coffee, you write your book. It's totally easy. Have fun. It takes like a month.
Greg Charvat's been trying to convince me to write a book for like a year and a half now. And this is what I'm saying. It's like, he's like, oh, it's simple. And I'm like, no. And so it's not easy. What about doing a book like this though? Because this is a little bit less, I mean, this is very technical actually still, but it's still like a higher level. It's wrapped nicely in like good writing and everything else like that. It's not just equations or just code snippets. So does that make it different, or
yes?
How did that all work?
Well, and the artist that worked on my book took chicken scratchy little things and really nice drawings. So that was important.
Yeah.
Okay, so I spent probably 3 to 5 hours a day for 6-7 months writing a book.
Holy crap.
Wow.
And I had a job at the time, a contract job, and they were very understanding, and that was cool. And O'Reilly wants you to work with them. They don't want you to come with a fully formed book. They want to help you through the process. So that
I think almost all of them do that. Yeah.
I think Pragmatic Press wants you to be a little further along. They want to see that you're going to write the book. The way that I did it with trying to insert as many jokes as I could and trying to keep it engaging to read. I mean, there are a lot of books out there that you read the section you need and then you put it down. But my goal was to write something that you take to the beach to feel like you're not entirely slacking off from working, but then actually get engaged. So I did, there's a fair amount of humor. So I think that's harder. And I minored in theories of learning, so cognitive psychology stuff. So I really care about how people think, and I try to do a bit of that. And O'Reilly does the Head First books, and I think I kind of straddled their ranges. It's not as technical as some of the other ones in the animal line, but it's not quite as fluffy as the Head First, really thick ones that you get a lot of puzzles in.
Wait, what's Head First mean?
Oh, Head First is O'Reilly's other line of books, and they tend to be 400 pages. I mean, big, thick books. But each page has a graphical element and like a puzzle element, as well as the technical information they're feeding you. And the goal is to make it easier to pick it up and to learn it and to internalize it, instead of the technical books where you really have to make yourself read it. Head First are a lot more fun to read, but they're huge, so there's a trade-off.
Well, that's cool. That's good to know. And I mean, like I said, I haven't gotten through all of it yet, but I mean, I really do. I do like it. It's, for someone like me who complains about code a lot, it makes it a lot more accessible. So,
and is it the same with most authors that really, if you're doing it for the money, you're doing it for the wrong reason?
Oh yeah, I mean,
totally.
Contracting rates, there's.
No. Yeah. You lost money. Yep.
I definitely lost money, and they still send me a check every month. But you don't do it for the money. The credibility is very high. The opportunities to do other things. I talked to James Graney. You mentioned him. He wrote test-driven development for embedded systems, or Embedded C.
Mm-hmm. Yep.
And he's a great
Embedded
guy.
C, yep.
And he wrote his book, and he does a little bit of consulting, but 90% of his income is due to teaching. And so the book is valuable for that. And it's great to get him teaching gigs, and it's great to leave with people. And when my book came out, I started to look at teaching and realized that I like teaching. I like talking to people, but I like talking to processors more.
yeah, these humans don't want to deal with
listen at least.
Human race, just an inconvenience.
It does exactly what I tell it to do.
And when not, you can just, have it overwrite itself 10,000 times in a row.
And we probably can't pass up the opportunity unless you had more to talk about the book. Yeah.
I just want to encourage Chris that it is very worthwhile, but it is a lot of work.
Yeah,
and
it's a ton of work.
If you're thinking about it, and you're thinking about it in like a 2-year sort of way, consider doing NaNoWriMo. It's November's National Novel Writing Month, and you write 50,000 words in a month. And if you can do that, you can write any book you want. And if you only get to 5,000 words, then really you may not be able to push yourself. They don't have to be good words. They just have to be words.
just words.
The.
Can they all be participles?
But you do a lot of writing already. You do blogs and contextual electronics is going to end up having a ton of material that we'll be able to translate into a book. So you're not starting from zero. So all of my laughter aside,
sounds good.
Seriously consider it. I'll try not to giggle.
Fail.
You are speaking at EE Live, is that right? The former Embedded Systems Conference, then Design West, now EE Live?
Yes, because, they have to change the name again. I am speaking at EE Live.
Yeah, they got to throw out all those hats and T-shirts and stuff. They want to throw them out each year.
I'll be speaking Wednesday at noon with Jen Castillo. We are going to tear apart her BS Sports watch and look at the inside. And her slides are incredibly upfront with what they're doing inside their product. So I'm excited about the teardown, and that anybody can do it. It's on the expo floor. So you get the free expo pass. You can come see me and Jen.
Oh, yeah.
And then my session behind the paywall is what marketing won't tell you about the Internet of Things, in which I rant about how the Internet of Things is not what everybody promised us. And we need to do a better job at making it accessible to consumers.
No kidding.
So,
Yep.
So they don't want to configure everything themselves? They don't want to pound define their thermostats and
the configuration is the huge hideous part, and security and ease of use are natural enemies, and just all the stuff that when you're thinking about should my fishbowl be connected to the internet, sure, absolutely, all fish should get to surf the internet, but there are some things you need to think about when you are looking at making it low cost and how that's going to affect your fish and his ability to get to YouTube.
Come on, Google can't be wrong. They paid $4 billion for Nest for a reason. Okay?
Yeah, right.
I have a Nest. I have Nest Protects, the smoke alarm. I was so excited about having a smoke alarm that didn't suck, and I have to say the setup sucked. And then
what is wrong with the smoke alarm? How does a smoke alarm suck? It sits there. It never does anything. It never intrudes in your life. How does it possibly suck?
Well, the configuration
because there's a low
sucked.
battery warning once every...
No.
How? You stick it up on
had-
the roof. You put a battery in it.
We had a false positive. And because it is internet-based, it texted us. And we were 20 minutes away. And it was...
And you burned the house down or something? You're like, better just...
annoyed the crap out of all our neighbors and gave us a heart attack because, getting home because you think your house is on fire.
A false positive from what? You can mitigate these things.
Well,
It's
okay,
not rocket
maybe
science. You
there
burn the
was
toast,
some
okay?
blame there.
Smoke alarm goes off.
They say don't put it in the garage. We have an electric car, so we put it in the garage because we don't have carbon monoxide, so it should be fine. And there may be more than one reason not to put it in the garage. So maybe it was our bad, but still.
So it was user error.
I've got a smoke alarm in the garage. It's never given me a lick of trouble in 10 years.
Are the batteries dead?
What's the problem?
Yeah,
I
it's been dead
replace
for
it.
10
No,
years.
they don't run dead because I replace them every year.
I don't know. I since I have an electric car, I actually want a smoke alarm in the garage just in case.
Then put one in there.
But don't put a Nest Protect.
You don't
Dave's saying
need this
don't-
newfangled Nest
don't-
rubbish.
Yeah.
Don't hook it up to the internet. That's
Yeah.
what Dave's saying.
That's what I'm saying.
Well,
Buy a $10 smoke alarm for your local thing
Yeah.
and put it in your garage.
So is it you
don't get
actually
it.
actively dislike it then, or is it just that you don't feel like you got what you paid for?
Well, I called them and explained the whole situation with the electric car and the garage and asked for help. And the guy read what he was instructed to say over and over again. And I said,
Script.
can I speak to a manager? And he reread the script.
Oh man.
So I went from kind of being annoyed, but realizing it's my own damn fault, to actively not liking them. In part because of their internet setup was stupid. Actually worse than their Nest
Yeah.
thermostats version, which was lame.
And Google paid how much?
I know.
Why?
$3.2 billion.
Google, if you'd liked biological elegance, it's a reasonable price. $100 million gets you a lot of experience with embedded systems.
Exactly. You get a lot.
And that's just lunch money for them.
A whole stock full of dev kits, tools.
Yeah.
Yeah.
Heck,
Oh, man.
heck, you'll even throw in the podcast at that price.
Right.
So that begs the question: how much would you sell out for? That's all.
I think she just said 100
Yeah.
million.
100 million.
So.
I think I'm going to stick with 100 million until I know the rest of the parameters. there.
Right.
So we have taken more than enough of your time, and
I thought these were 4 hours long.
you want to go 4 hours?
No,
Dave, you up 4 hours?
no,
Okay, I'm just saying.
I was just about to say I'm getting hungry. I should go have some dinner.
But people, the difference here is that people can hear you every week, which is, so they can just go over there, and they should go over there. Embedded.fm, my new favorite podcast.
And they can hear that
I
lovely
don't miss it.
voice.
Thank
I'm
you.
so jealous. I hate anyone who's got a good voice because mine sucks. And somehow I do a radio show. You've got that lovely
And people like
mellow
to listen
voice.
to you.
It's,
So
I think they put up with me. I think they.
Yeah,
I
we
think
do.
for some reason they tolerate my voice.
I really like your your interaction with guests is good, but I actually like when you and Christopher are on together. I like you guys just have a really good rapport together too. Like you kind of like
thank you.
yeah. I just think it's it's like
That's why they're married, dude.
it's exactly that's exactly it. Like so.
We are coming up on 20 years together, so we should
Whoa, geez,
have
you
a
get
bit
less
of a
for
rapport
murder.
at this point.
As I always tell my wife. Yeah.
Yeah, if you,
I get in trouble every
if you
time.
made it this long, you guys are doing something right. So that's good.
But we are incredibly fortunate to have not similar careers entirely, but enough that we can definitely talk about what we're doing and how it works. And
That's
I like
nice.
to talk to him.
That's good.
Sometimes I even like to talk to him with microphones on.
Some people think that's a bad thing, to have a partner who likes and does the same sort of stuff you do and works in the same industry and all that sort of, jazz. There's for and against. Some people, think,
I
it's
think
the
you're
best
doing
thing
the
ever.
exact
Other
same
people
thing.
say, no way, don't do it. Marry someone completely different with completely different hobbies and...
I know that he's going to listen to some of this podcast, but I don't know he'll make it all the way. So I will
All
say
right, we're safe.
that we have the shared consulting company, and we
Even
have an
worse.
office. We actually have a
Ooh,
really
yeah.
nice office in our home, and our backs face each other, so we don't see each other all day, which I think is important. But I have been with the robotics company. I've been going to client site because the robot's there, and I didn't really want to burn down my own house.
Yeah. your
so-
Nest won't help you. It's in the garage. Why would you beep? Damn it! Just beep. Don't talk to the internet. We don't care. Sorry.
It has been so nice being out of the house and not being with him 24 hours a day.
Oh yeah.
So you do need a little space.
Oh yeah.
Right.
But yes, now that I'm getting a little more, it's great. And
Might make it to 21 years then, huh?
maybe
All right.
we'll see.
Oh, goodness.
Okay, so I want to say my podcast thing. That.
Oh yeah.
Please
So,
do.
welcome to Making Embedded Systems, the show for people who love gadgets. Okay, that was all. Thanks.
That voice gets me every time.
Why did you want to say that?
Well, because you said embedded.fm, which is where to find the RSS
Oh,
and all of
yeah,
that.
sorry.
But the show name is Making Embedded Systems. So I just wanted to get that out there. And the tagline, I worked hard on that tagline. It took me all of 10 minutes.
Did you buy makingembeddedsystems.com? That might just make it easier on people.
Yeah.
Yes. And it used to be contact this show through show@makingembeddedsystems.com. But people were telling me they were getting bounces, and so now it's the show at embedded.fm because it's easy.
It's 3 words. Goodness. That
We're
breaks
3
every
words.
rule of domain names, doesn't it?
We're 3 words.
Yeah, but we're short
That's
words.
true, the amp hour.
Yeah, we are. Oh, okay, well, fail. Okay, I'll retract my comment. Yeah, but we're short words.
We are short
Now
words,
I have
that's
to
correct,
justify our 3-word domain name. You know.
That's right, yeah.
Yep.
Changing the show name.
Wander off with my tail between my legs.
Yeah.
Yep.
What about if people? We will post a link to the book as well because I highly recommend people buy the book. What if people want to hire you as a consultant?
Info at Logical Elegance is our general. And
Okay.
if you go to Logical Elegance, it is logicalelegance.com.
Okay.
If you want to buy the book, coupon code is AUTHD, AUTHD, Alpha Uniform Tango Hotel Delta.
Okay.
I'm writing it down.
Yeah.
You got to give everybody time to write it down.
Right.
And that's only useful on O'Reilly.com. But
Okay,
yeah.
that's good. O'Reilly.com. Well, thanks for being on the show.
Thanks for having me. It's been
We'll have
fun.
you back for sure.
And,
We can.
I am so glad you guys exist too.
Good,
I wish I had
yes.
known more about. I wish I had known about the amp hour when you started.
Well, no, because then
it
you
kinda
said you wouldn't have
sucked when we
started.
It was, you know.
Yeah, we did.
It's slightly less sucky now.
But it's so useful. You always wonder what the other guy's doing at their desk, and it's nice to hear what the electrical engineers are doing. So thank you.
Technological voyeurism. That's my new term. So I totally agree. That's what contextual electronics is based on.
Oh, dear.
All right,
All right.
yeah. So
Thank
people
you
should
very
go
much.
listen to Making Embedded Systems, the podcast, not embedded.fm, but located at embedded.fm.
It is confusing. Thank you for having me.
That's all right.
It was an honor and privilege, and thank you.
Thanks for being on the show.
Bye.
How do we say goodbye?
We'll probably just keep dragging it out. I'll just put a chop in here somewhere, and then, this will go in the post.
Damn it, I'm hanging up now.